Hello everyone. My name is Wu Yu Ru and today I will be presenting on a survey of speech recognition for people with cerebral palsy. This article explores speech recognition for individuals with cerebral palsy, using speech models to identify and investigate their speech patterns. My advisors for this research are Professor Chang, Jia-Wei and Professor Hongqi Shun. This is my outline. I will introduce it one by one in a moment. Individuals with cerebral palsy suffer from brain damage that severely affects their language abilities. This impacts their social and daily lives, causing them to struggle with producing correct SIL. This study aims to record audio files of individuals with cerebral palsy and collect the correct transcriptions of their speech, in order to provide a self-made speech dataset for individuals with CER. In the early 1960s, speech recognition technology was mainly based on pattern matching methods. Pattern matching involved comparing the input speech to pre-stored speech templates to determine the con. However, contemporary speech recognition systems could only recognize basic single-sentence speech in the late 1970s, and the Hidden Markov Model (HMM) method was introduced. This method involves CRE. In the 2000s, with the development of deep learning, methods based on deep learning emerged. Deep learning utilizes deep neural networks to learn speech features, thereby improving speech recognition. In the early 1990s, neural network methods emerged as a type of speech model that can learn and adapt. These models can be trained using the backpropagation algorithm, resulting in higher accuracy. Overall, speech recognition technology has continuously advanced, evolving from pattern matching, hidden Markov models, and neural networks to deep learning and end-to-end learning methods. This has Speech models play an important role in the field of speech by leveraging knowledge bases to make predictions based on contextual information, and providing appropriate phrases. Through pre-training by inputting a speech signal and analyzing its spectrogram, changes in the speech waveform and acoustic features such as speaking speed, intonation, and volume can be observed. In summary, early speech recognition technology was developed based on pattern matching, until the current speech recognition technology was developed using deep learning-related techniques. Speech recognition technology was developed using deep learning-related techniques. Speech recognition technology has continued to evolve, and with the birth of new technologies in the future, speech recognition technology will receive attention and be widely applied. The analysis and ranking of speech recognition results for individuals with cerebral palsy were conducted using 3 speech recognition models: Google, Microsoft, and Yachting. The recognition results of the 3 speech recognition models were analyzed using the word error rate (WER) scoring tool to determine the accuracy of the speech recognition models. CER, character error rate, MER, matching. Error rate, WIP, word information preservation, and WIL, word information loss, are the most commonly used evaluation metrics for speech recognition, and their mean, median, maximum, minimum, and saint standard deviation were obtained for individual comparison. CER stands for character error rate, which evaluates the similarity between the original speech text and the recognized text. The lower the CER value, the better the similarity between the two. S represents the total number of substitution errors. D represents the total number of deletion errors. I represents the total number of insertion errors. N represents the total number of correct char. The lower the MER, the better the OSR system is at accurately recognizing speech. S, D, and I represent the total number of errors made by the OSR system, while H represents the total number of correctly recognized letters. MER is an important metric for evaluating the performance of OSR systems. Here, C represents the number of words in the original speech signal that are accurately preserved in the recognized text output, and N represents the total number of words in the original speech sign. WIL stands for Word Identification Loss Percentage, which represents the result of subtracting the recognized speech text from the original speech text, indicating the degree of loss with a higher val. The CER represents the accuracy rate, and a lower rate indicates better recognition capability. Among the 4 evaluation indicators, the average CER of Microsoft's speech model is 93%, compared to Google's 104% and Yating's 126%. The median CER of Google is 93%, Microsoft is 89%, and Yating is 100%. The maximum CER of Google is 500%, Microsoft is 450%, and Yating is 600%. The standard deviation of Google's CER is 83%, Microsoft's is 32%, and Yating's is 73%. Therefore, Microsoft's speech model performs better in terms of CER recognition ability. The MER represents the word omission rate, and a lower rate indicates better speech recognition capability. Among the 4 evaluation indicators, the average MER of Google's speech model is 66%, while Microsoft's is 74%, and Yating's is 89%. In comparison, the average MER of Google is much lower than that of Microsoft and Yating. The median MER of Google is 75%, Microsoft is 86%, and Yating is 100%. The median order is Google, Microsoft, and Yating. The maximum and minimum values of the 3 speech models are all 100% and 0%, respectively. The maximum and minimum values of the 3 speech models are all 100% and 0%, respectively. The standard deviation of Google's MER is 37%, Microsoft's is 32%, and Yating's is 15%. The standard deviation order is Yating, Microsoft, and Google. The order of average MER is Google, Microsoft greater than Yating. WIP represents the percentage of unidentified speech in the total amount of speech, and a higher value indicates better speech recognition ability. Among the 4 evaluation indicators, in terms of WIP, the average value for Google is 28%, for Microsoft is 19%, and for Yating is 5%. For Microsoft, and 0% for Yating, and the order of median values is Google, Microsoft, and Yachting, respectively. The maximum and minimum values for the three speech models are 100% and 0%, respectively. The standard deviation for Google WIP. The maximum and minimum values for the three speech models are 100% and 0%, respectively. The standard deviation for Google WIP is 36%, for Microsoft WIP is 31%, and for Yachting WIP is 10%. The order of standard deviation values is Google, Microsoft, and Yachting, respectively. The order of average values is Yachting, Microsoft, and Google, respectively. The median values for WIP are 7% for Google, 3% for Microsoft, and 0% for Yachting, and the order of median values is Google. The average WIP values are in the order of Google, Microsoft greater than Yachting. WIL represents the percentage of identified speech in the total amount of speech, and a lower value indicates better speech recognition ability. Among the four evaluation indicators, in terms of WIL, the average value for Google is 72%, for Microsoft is 97%, and for Yachting is 95%. The order of average values is Google, Microsoft, and Yachting, respectively. The median values for WIL are 93% for Google, 97% for Microsoft, and 100% for Yachting, and the order of median values is Google, Microsoft, and Yachting, respectively. The maximum and minimum values for the three speech models are all 100% and 0%, respectively. The standard deviation for Google WIL is 36%, for Microsoft WIL is 31%, and for Yachting WIL is 10%. The order of standard deviation values is Google, Microsoft, and Yachting, respectively. The average WIL values are in the order of Google, Microsoft greater than Yachting. Based on the above four evaluation indicators and the testing data of 2,000 speech files, 500 sentences were selected as the EVA. The order of speech recognition ability is Google, Microsoft greater than Yachting. Each of the three speech models, Google, Microsoft, and Yachting, has its own advantages. Google performs better in MER, WIP, and WIL, while Microsoft performs better in CER. However, these speech data only represent the results of this evaluation. In reality, the speech recognition performance of the models may vary depending Most patients with cerebral palsy often experience speech problems. Through the use of speech recognition technology, we investigated whether Google, Microsoft, and Yachting can recognize speech from in daily life. A large number of vocabulary can be converted from speech to text using model parameters and feature extraction. This process can be customized based on different languages, speech rate. As an individual with cerebral palsy, I collected speech data and investigated speech recognition models available in the market, including Google, Microsoft, and Yachting. I tested the speech data using these models and found that Google's speech recognition model had better performance in identifying speech patterns.